Good morning, class. So today we're looking at the statistics. We're looking at the examples for exercise 13.5. So yesterday we did the OJF graph. It's often asked in exam, and in the grade 12 exam as well. Today we're going to look at variance and standard deviation. So it's 13.5, and this one page 450, 466. Okay. So variance and standard deviation. The median is one measure of central tendency. The central values or central tendency values are values that tells us about the ideal number for the data set. We have to choose one value. What does that value tell us about the data set? Okay, what that value indicates. So the median is one measure of central tendency or middleness. And the quartiles indicate the dispersion or the spread, dispersion means spread, about the median. Okay, around the middle value. The mean is another measure of central tendency or the middleness, and the standard deviation gives the dispersion, which is the spread around the mean. Okay, the standard deviation is denoted by the symbol. It looks like a circle with an extended line there, but that is the Greek small letter S and called sigma. The capital S in one's name you're also exposed to, and that is capital S in the Greek. Okay, and we work with that. We call that sum. No, sum. There is small s, which also means sum. Okay. The symbol for variance is your standard deviation square. Thus, your standard deviation is equal to your square root of the variance, which is our standard deviation. The standard deviation can be calculated manually using a table, or can very easily be determined by using a calculator. Now, people, there are two ways of calculating your variance and your standard deviation. Okay, one is by using a table, and the other one is by using a calculator. Now, never do they ask you to use a calculator, the table. So I'm not going to show you how to do it, okay? Because of our period being a bit shorter today. So, if you really want to know how to do it without a calculator, you can go through the textbook. It's on page 59. And you can see how they're actually using the table in order to calculate the variance and the standard deviation. Okay? But again, we don't need that. We don't need to use the table. Okay? And because of there's a lot of calculations involved there. A lot of calculations for the table. So the chance of you making a mistake is high. You guys understand? There's a calculator. It goes quick, and you can even exam. If I'm you, I test it twice, just to be sure that I got the correct values there. Okay. So we're looking at the example. This example is on page 415. So here the question says determine the variance and the standard deviation for the following set of marks out of a total of 100 for a group of 10 learners. So variance and standard deviation. So what did we say? Your standard deviation is equal to the square root of your variance. Not so. So your variance has to be equal to standard deviation squared. Just remember that, okay? So what we're going to do is we're going to program a calculator in order to calculate these values or the variance. Okay. We'll take your calculators out. Some of your calculators seeing the light of day for the first time since you wrote your exams, no? We must not people that works on our own and stuff like that, no? Do our own working. Okay. Where's your calculator on? So what we're going to do is we're going to program this calculator so that we can calculate the standard deviation and the mean. Okay. Calculate standard deviation and mean. Calculate standard deviation and mean. Write that in your books. Calculate standard deviation and mean. Yes? Sorry? Wait. Okay, so where do we start? We're going to start by pressing mode. So press mode first, okay? And then you press 3 for step. Okay. Now if you're going to use a black calculator, I think, or the pink one is 2 for step. Not so? So if you see 2 for step, don't press 3. Okay. So I press 3 for step. You pressing 2. Then we're going to press number 1 for first variance. 1 variance. Okay. You all see that? So what do I do now? Now you see a table there. You all see the table. Who doesn't see a table? Who doesn't see a table? Okay, so what you're going to do now is you're going to enter the data. So we go 78. Now to enter this into the calculator as number entry 1, I press equal. Okay. So see, where's your calculator? Take one out of the drawer, you can allow my girl. Who doesn't have a calculator? Pull, pull, pull. Get to this point quickly. Mode 3, no, you're done. Okay, 78. The next one is 51. Again, you press equal. The next one is 88 equal. The next one is 45 equal. The next one is 60 equal. The next one is 70 equal. The next one is 74, 64, 58 and 82. Okay, we all got it. So once we have entered the data, once we have entered the data, you all got to this point, no? Once you have entered the data, you press AC, all clear. So by pressing AC, we have stored the data now in the data set, into the calculator. Okay? So at this point, we're going to press AC. Then we press Shift number 1. So press shift number 1. Now why do you want to press number 1 is you see there in yellow this stand stat and I don't know what's this, probably what is that, the D, or what word is it, distribution, what's standing? You only stat on that calculator. Okay, I can't clearly see what this is. Stat and then there's a slash something else. Might be distribution or something, looks like a D or something. But we're going to, by pressing stat, I've activated all these yellow keys in the calculator. Can you see that? So I press 1, I'm activating the stat key again. Can you see that? Then you're going to go for? What do you think you're going to go for? 2. 4. Why 4? Variance. Okay. So you're going to go 4 variance again. What is the number on your calculator? It's also 4.
Yes.
Okay. Press 4. Now you see that 2 means that is the mean. So if you want the mean, you press 2. Or if you want the standard deviation, you press 3. So what is the mean? Press 2 equal 67. So the mean of this data set is 67. So what's the standard deviation of this data set? So how do we get to the standard deviation? You again press shift 1. 4 for variance, 3 for, you see that 3 here is standard deviation, okay, which is 13,13. Yes. Sorry? Did you press equal? Hey! You cannot press equal. You must press equal to get the answer. Do you guys understand? That one, yes. What don't you get? Standard deviation. You press again shift 1. 4 for variance, 3 for standard deviation. Equal. What's your answer?
13,13.
There we go. Anybody else? Amber, you okay?
So mine is 13,84.
84. Then you made a mistake. Okay, so what I want you to do is press shift 1, your data set 2. Now you read your numbers out. 78, you must have gotten that one right, yes?
78, 51, 88, 45, 60, 70, 74, 64, 58, 82.
That it? So your data is correct. So press shift 1. Okay, this first press AC. AC. Shift 1. 4 for variance.
No, sir, I read it, but I would type daughter even. And shift.
1.
No, it's technical sentence.
Press AC twice.
Okay.
Shift 1, 4 for variance. 3 for standard deviation.
Okay, so you're nasty.
Okay. Anybody else? So what did they ask you to calculate? Your standard deviation and your variance. And what did we say about the variance? It's going to be your standard deviation squared. So let's just say 13.13 squared. Oops. 13.13 squared gives us 172, 13.13. 39 or 40. 172, comma. Okay. People say any confusion there? Okay, now a common asked question. I think it's probably going to come in the next example. A common asked question is to calculate how many values lies within one standard deviation of the mean. Okay. Determine the number of values. Is not asked here. So again, I'm going to put it in red here. Determine the amount that lies within, one word, one standard deviation of the mean. You can write this question down. Determine the amount of values or players or whatever this represented, marks. Determine the amount of tests that lies within one standard deviation of the mean. Okay. So to calculate this, we say we set up a range. Okay? We set up a range for this data. So we say it's going to be your mean minus your standard deviation and your mean plus your standard deviation. Determine the amount of marks. Write it down, don't look there. Determine the amount or the number of marks that lies within one standard deviation of the mean. That's what stands there. Okay. So what we do is we got our mean, we got our standard deviation. Not so. So what we do is, what's our mean? 67 minus your standard deviation, which is 13,13. And you got 67 plus 13,13. Okay, so you got 67 minus 13,13 gives us 53,87. And then plus 80,13. Okay. So what have we done? We set up a range now. Okay, for this data set. So whatever lies between 53,87 and 80,13, anything between that lies within one standard deviation of the mean. But we'll explain to you now, for informality, how that actually pans out. So remember, our set of data is must lie between 53,87 till 80,13. Now, is 78 inside or outside this data, this range? It's inside. So that is within this data set, this range. Can you see that, people? 51? It's outside. 51 lies here. Not so? It's outside. 88? Outside. 45? Inside. Outside. So it's far less than 53. 60? 70? 74? 64? 58? 82? So it's 1, 2, 3, 4, 5, 6. Therefore 6. 6. Therefore 6 lies within one standard deviation of the mean. Did you see that? Easy. No? We'll do another sum like that probably coming up soon. But that's basically what they ask us with regards to this question. Okay.
Sir, I don't understand those one.
You understand how I got the range?
Yeah.
Okay, so what I did was I just counted how many values is lying between those values, that range. Okay. So why didn't we say 51? Because 51 is less than this. 88 is more than 80. 45 is less, and 82 is more. Okay. Anything else? You all understand? Not Kelsey. Kanya. Lisa Kanya. You with us now? Nice. Alright, people, you got it? Huh? Don't lose it, okay. Recap. The standard deviation is a measure of statistical dispersion. Remember, it's spread. Simply put it, a way of describing how the spread out of the set of values is around the mean of that set. Having the mean of marks achieved by a class does not tell you anything about the spread of marks. Were there any especially high or low marks in this class? So in this class, was there any high or low? Okay, there was quite a few high marks then. Okay. So what happens is, if you work out your mean, okay, and there's a vast spread of data, okay, say there's a lot of people at the bottom end and a lot of people at the top. So your mean will be in between. Your mean will be midway between them, considering all the values. Okay? So your standard deviation will tell us if this data is far apart or if it's close together. So if your standard deviation is small, a small value, then that means to say it is close together. Can you see that, people? Your standard deviation is far apart, your range is big, then your standard deviation will also be large. Like for argument's sake, if we look at this here, the lowest value is 51 and the highest value is 88. Can you see? So the spread of data is large. Can you see that, people? Hence, the standard deviation is 13,13. Can you see that? But again, if the standard deviation is small, which means to say the data is clustered close together. Okay. So let's just carry on reading here. Having the mean of the mark achieved by the class does not tell us anything about the spread of the mark. Where there are any, especially high or low marks in the class, it is possible that you could have exactly the same mean average for the very different groups. Knowing how spread out the marks are compared to the mean gives you extra information over the above the mean value. A set of values that are closely clustered near the mean will have a low standard deviation. This is exactly what I said earlier on, not so. And a set of numbers that are widely spread will have a higher standard deviation. For data that is normally distributed, the normal spread of data, the standard deviation gives us the following information. Around 68% of the data is within one standard deviation of the mean. 95 of the is within two standard deviation, and 99 is within three standard deviation. So if you look at here, how many values are here? This was 6 out of, there was how many? 10, eh? No, 9, 10. 6 out of 9, which gives you 6 out of 10, which gives you 60% of the data lies within one standard deviation of the mean. Can you see that, people? But here, a normal spread is at 68. So that is 8% lower. Can you see that? To the normal, okay. People, let's look at example 1. Example 1 is on page?
463.
Sorry?
463.
463. Okay, I'm going to make another video on this. So I don't want it to be too long. The full listing can be found in the description box below.